Hi, my name is Valentina Bernal and I will present my master thesis project. After COVID 19, cycling became a healthier and a more sustainable alternative. However, in cities like Dublin, still face challenges when expanding this bike sharing system efficiently. My research question is what impact can the application of clustering and graph neural networks algorithms have on optimizing the expansion strategy of Dublin's bike sharing system and how the integration of these approaches can improve efficiency and customer satisfaction. So my methodology followed six key steps. The first one was the data collection using by history usage per month from last year 2024. Also a GeoJSON file using the small areas from Dublin. After this, all the data preprocessing and spatial enrichment, which I use sociodemographic data, then the clustering to identify patterns in demand, after the graph construction and node labeling, then the GNN model training, and finally the prediction and the visualization. This pipeline combines unsupervised learning and deep learning to suggest potential new locations. I apply K-mean clustering to group areas based on availability, commuting modes, age, and occupations. So you can see the results. For cluster 0, this had the highest bike availability with 12.28 bikes per station and the highest occupancy rate with the 37%. Cluster 1 had the lowest availability with 10.26 bikes and the lowest occupancy rate with 31%. Cluster 2 had a moderate values. And then finally, these patterns help to define where to place the new locations. I test multiple GNN models, for example, GCM, GraphSash, and GAT, with different variations like focal loss and batch normalization. The best performing model was GCN with focal loss and no leakage information. This model got an accuracy of 98%, precision of 94%, recall of 100%, and a F1 score of 97%. This means the model accurately predicts new stations while minimizing false positive. Those maps shows the predicted stations. The blue spots are the real existing stations and the green ones are the suggested stations. So on your left you have the graph size and focal loss. That was the second best model. So the predictions tend to cluster closer to existing stations, especially in high demand zones like Inner Dock or the Grand Canal Dock. That suggests that it's more sensitive to usage patterns and sociodemographic features. On the other hand, you have the GCN with focal loss and no leakage informations. Those predictions are more dispersed, reaching underserved areas like Phoenix Park, as you can see here, and suburbs. It suggests that it detects spatial gaps better and generalized more due to test node disconnection. Now I'll briefly show a demo of the code that I use. Everything was built in Python using PyTorch geometric and GeoPandas. So well, first I just imported all the necessary libraries as all the general purpose, data visualization, geospatial processing, machine learning and preprocessing, PyTorch, as I told you. Then I upload my bike summary from last year and the GeoJSON file. I just created a cluster in here without the enrichment data. That's just to know how was at the beginning. And upload the dataset with sociodemographic data with age, commuting modes, and employment. After all the enrichment, I just got my final dataset and I just create the clustering. Those are the same results that I just showed you in the presentation. And then I just started with my different variations of the GNN models. So in this case, I'm just gonna show you the best model that was the GCN with focal loss and no leakage information. So before building the graph, I create negative samples by shifting the coordinates of real stations. These provide examples of points close to the real ones, but not the actual stations. This helped the model learn to distinguish between suitable and unsuitable locations. In this case, when I create all the negative class, I just combine the positive and the negative, and then I just started to build my graph. So in this case, each node represents either a real station or a synthetic or negative sample. Agers are created based on spatial proximity using the k nearest neighbors, and labels are 1 for real stations and 0 for negative that was created using jittering. And then I just defined my model using focal loss. Just to handle the class imbalance, I evaluate the model and I got those results. And then I just started to predict and visualize the suggested stations. So for the prediction stage, I generate 50 random candidate points across Dublin. This ensures a variety in the test sets, covering both central and suburban areas, while keeping the results easy to analyze and visualize. I scale the candidate features and then I just break probabilities with train on Likert model. And in this case, I choose a threshold of 0.3 because first maximize the F1 score invalidation, increase the recall for underserved areas, and maintain good precision. For example, at 0.5, too many good candidates were missed, but at 0.3, it was the coverage improved with minimal false positive. And finally, I just visualize. So I just show you, as I just showed you, all the blue spots are the real ones and the green ones are the suggested stations. So the model avoids placing stations too close to existing ones and covers underserved areas like the southwest and northwest from Dublin. So this study aimed to enhance Dublin's bike-sharing network using clustering and GNN. So as a conclusion, we can conclude that clustering identifies demand patterns and underserved zones. Sociodemographic data used to enrich the dataset improve the model accuracy. The GNN models effectively learn from complex spatial patterns. For example, with GCN model with focal loss and no leakage information, this achieve an F1 score of 97%. So this approach supports the smarter, more equitable and more efficient expansion of the bike sharing systems. Thank you.